We're starting on the topic of circles next. So we're going to start off fairly straightforwardly. That is, with a circle centered on the origin. If it doesn't look centered on the origin, it's because my drawing's a bit duff, but never mind. Centered on the origin and radius r. Now, the origin just means 0, 0. And the equation for that is x squared plus y squared equals r squared. Which makes sense if you think of it, because x is the x coordinate, y is the y coordinate, and r is the distance to the circumference, which doesn't change. So it's basically Pythagoras' theorem, isn't it? If you look at it round here, every point on the circumference of the circle, the x coordinate squared plus the y coordinate squared will be equal to the radius squared. The other thing that's mentioned you'll find on the questions is concentric. All that means is it's got the same centre. So if I say two circles are concentric, they have the same centre, but they'll have different radii. Okay, so let's do this. Right, let's write down the equation of a circle with centre the origin and radius r. Well, we know it's x squared plus y squared equals, and then the radius squared. Well, 5 squared is 25, isn't it? So that's why it says write down, because you could write it down. Next bit, it says find the equation of the circle concentric with that. Well, look, it's x squared plus y squared equals r squared. So that is centered on the origin, isn't it? So we know if it's concentric with that, the new circle will also be centered on the origin. So it's going to be x squared plus y squared equal to its radius. Now look, r squared there is 4, so r equals 2. So I wanted twice that radius, so I'm going to have r would be 4, yeah, that times 2. So the new radius squared will be 16. So the number that goes in here is 16. Okay, so square root of that was the radius of the original circle, which was 2. So the new radius is double that, because it said it's twice it, which is 4. Square that, you get 16. So it's x squared plus y squared equals 16. Let's look at this last example. It's asked me to show that these 3 points are equidistant from the origin. Remember, equidistant just means of equal distance from. So, if I want the distance OA, I use my distance formula. But as O, the origin is 0, 0, it's just 5 squared plus 12 squared. Or 5 minus 0 and 12 minus 0 squared, if you prefer. But that'll just give you 13. Similarly, OB, you're going to have 13 squared plus 0 squared, which again is 13. And lastly, OC. Remember, if you square them, they become positive. Okay, so we can say, therefore, A, B, and C are equidistant from origin. Okay, which is what we're asked to show. Then it says state it, because it's obvious. We know the distance from the origin is 13. So that's the radius. Okay, so what we have is we just have x squared plus y squared equals 13 squared, which is x squared plus y squared equals 169. Okay, because they're all 13 from the origin. It says write down an inequality to describe the points outside the circle. Well, if they're outside the circle, the distance must be larger than 13 from the origin. So that means that x squared plus y squared must be larger than 169. Okay? If it had been inside the circle, it would have to be x squared plus y squared, which is the distance, remember the distance squared, would be less than 169. And obviously 4 being on the circle, it's equal to 169. Okay, so they give me the last bit here. They've said, look at this point, H96. Does it lie inside, on, or outside the circle? Well, let's work it out. X squared plus y squared for this one is equal to 9 squared plus 6 squared. That's 81 and 36. What's that? 117. Okay, therefore x squared plus y squared is less than 169 and h is inside the circle. So, remember, on the circle, it's x squared plus y squared equals r squared for a circle centered on the origin. Outside that circle, it's greater than it, and inside the circle, it's less than it. Should now be able to do all the questions in the first exercise.